So imagine you are listening to Redbone by Childish Gambino on your way home from work. What happens is that your radio is going to play sound waves, but our brain can't interpret sound waves, so we need to have our ear to change the sensory information into something that our brain can compute. So first, the waves are going to come in through the pinna, which is this outer ear right here, and it's going to bounce through the auditory canal. There is, right here, it's our outer ear canal, but it's also, like this specific is the auditory canal. It's going to bounce through, and then it's going to hit our eardrum where the hammer is attached to. The hammer is up here. The hammer is a tiny little bone that passes the vibrations from the eardrum to the anvil. And the anvil is going to be passing from the eardrum to the anvil. So here's the hammer. It's going to ring against this part, which is our anvil. It's not able to be labeled because it's not, there's no room. But this right here, the bulb, is the anvil, which is connected to the stirrup. The anvil, like I said, is a tiny bone that passes vibrations from the hammer to the stirrup, and then the stirrup is also a tiny U-shaped bone, and it passes the vibrations from the anvil to the cochlea. So the vibrations pass from the eardrum to the hammer, to the anvil, to the stirrup, to the cochlea. The cochlea, if you want to pull down here, this is our zoomed in version. The cochlea is a spiral shaped structure. It is fluid formed, which is shown by the white out here. And there's two main parts in the cochlea that we need to notice. The first one is the basilar membrane, and this also includes the hair cells, which is shown by the blue. And the hair cells is what actually, it feels the pause. When the vibrations come from the stirrup into the cochlea, the basilar membrane is just tissue. It's connected to the hair cells. But the hair cells, when they move, it actually excites the neurons, which get sent to, if you come up here, through the auditory nerves, gets sent to the thalamus, which is then relayed to our auditory cortex, which is within the temporal lobe, which is how we hear things. You can see attached to the cochlea, there are semicircular canals, and that is more for balance because there's fluid in these three canals. And so when you move, the hair, like, it feels the movement of the fluid. So when you spin around really quickly, but then you stand, you still feel like the room is moving. That's because the liquid inside your semicircular canals is still moving. So that's what helps us maintain balance. You can see right here that we have the eustachian tube, and this tube is a tube that connects from the middle ear, which is right around here, and it connects from the middle ear to the back of the nose, and it equalizes the pressure between the middle ear and the air outside. And so, like, when you pop your ear when you're changing altitude, that's what it's like repressurizing the air, making it equal.